ChatGPT, Gemini, Claude, Copilot. You're probably using one of these right now. But I need to tell you something. Every single one of them is doing the bare minimum. You type, they talk back. That's the whole trick. Now picture this, an AI that checks your calendar, plans your entire week, writes your emails, and actually sends them. No prompting it 5 times. No hand-holding. You blink, it's done. That's not the future. That's an AI agent, and it's already here. Here's the wild part. You don't need to code a single line to build one. If you can type a sentence, you can build an agent that works for you. So stick around, because by the end of this video, you're not just going to understand AI agents, you're going to know how to build one yourself. Let's get into it.
Let's start by answering a fundamental question. What exactly are AI agents? Now, to understand this concept, we need to think about the difference between passive and active systems. Now, most traditional AI systems that you might be familiar with work like very sophisticated calculators. You give them an input, they process it using their training, and then they give you an output. Now, this is what we call passive approach because the system simply responds to what you provide without taking in any independent action. Now, AI agents, they work completely differently. So these are systems that actively engage with the world around them. So instead of just waiting for someone to ask them a question, agents can observe their environment, make plans about what they want to accomplish, make decisions about how to achieve those goals, and then actually take those actions to make things happen. So think of the difference between a calculator that waits for you to enter a number versus a robot that can see a messy room, decide that it needs to be cleaned, figure out how to exactly clean it, and then actually start cleaning. So the key characteristic that makes something an AI agent is the ability to perceive and also act. Agents can gather information about their surroundings through various means. They can process that information to understand what's happening, and then they can use that understanding to influence their environment in meaningful ways. Now, this creates what we call an active loop, where the agent continuously observes, thinks, and then also acts based on what it actually learns. Now, a perfect example that most people can relate to is the self-driving car. So this technology represents one of the most advanced examples of AI agents in action. A self-driving car doesn't actually just sit there waiting for commands. Instead, it actively uses multiple types of sensors, including cameras that work like its eyes. It has radar systems that can detect objects even in poor weather conditions, and also other sensing technologies to constantly gather information about everything around it. So the car's computer systems process all of this incoming data to build a complete picture of the traffic situation, of the road conditions, pedestrians, and other vehicles, and also a bunch of different other factors that affect safe driving. But information gathering is only half the story. The self-driving car also has actuators, which are the mechanical systems that allow it to take physical actions in the real world. So these actuators control the steering wheel, they control the brakes, the accelerator, and other vehicle systems. So based on what the car sensors detect, and also what its computer brain decides is the best course of action, it can actually steer around obstacles, slow down for traffic, speed up when it's safe, and then also navigate complex driving scenarios. Now, what makes this even more impressive is that these systems learn and also improve over time. The car's cognitive modules, which are the AI components responsible for decision-making, continuously analyze new patterns and situations that they encounter. So every time that the car faces a new driving scenario, it adds that experience to its knowledge base, and then it refines its driving skills accordingly. Now, this means that the AI agents like self-driving cars become more capable and sophisticated as they gain more experience, much like how human drivers improve with practice. So this example illustrates the 3 core characteristics that define any AI agent: perception, decision-making, and action. The agent must be able to sense and understand its environment, process that information to make intelligent decisions about what it needs to do next, and then also have the capability to actually implement those decisions by taking concrete actions that change something in the real world. Now that we understand what AI agents are in general, let's focus on a specific and particularly powerful type called generative AI agents. So these represent an exciting evolution of AI technology that combines the autonomous capabilities that we just discussed with the creative and reasoning powers of generative AI. So to understand Gen AI agents, think of them as AI agents that have been enhanced with the ability to generate new content, ideas, and also solutions instead of just following pre-written scripts or rules. So traditional AI systems, they often work like very sophisticated filing cabinets. They can find and retrieve information that was previously stored, but they do tend to struggle to create something entirely new. Generative AI agents, on the other hand, can actually create novel and relevant responses, solutions, and outputs that have never existed before, while still maintaining the perception, decision-making, and also the action capabilities that define an AI agent. So what makes these systems particularly remarkable is their autonomy. So unlike traditional software that require detailed step-by-step programming for every possible situation, generative AI agents can independently handle complex scenarios by using the reasoning capabilities provided by large language models. So instead of a programmer having to anticipate every possible situation and write specific code for each one, these agents can encounter completely new problems and figure out solutions on their own by applying their underlying understanding of language, logic, and problem solving. The perception capabilities of generative AI agents extend far beyond simple data input. So these systems can work with text-based communications, visual information, audio signals, and various other types of input to build a comprehensive understanding of their environment. More importantly, they can interact naturally with other computer systems, databases, and even human users using conversational interfaces that feel intuitive and also human-like. This means that you don't need to learn special commands or technical languages to communicate with these agents. You can often just explain what you need in plain English. When it comes to taking action, generative AI agents excel at determining the best approach to accomplish their goals and then executing the necessary tasks to make it happen. They do this by selecting from a toolkit of available functions, arranging those functions in the right sequence, and then calling upon various tools and resources that have been available to them. Think of this like having a highly skilled assistant who not only understands what you want accomplished, but also knows how to use all of the different tools and systems in your office to get the job done efficiently. Now, perhaps most importantly, these agents are designed with goal-oriented behavior at their core. This means that they can take broad, complex objectives and automatically break them down into smaller, manageable steps that lead toward the desired outcome. For example, if you asked a generative AI agent to help plan a marketing campaign, it wouldn't just give you generic advice. Instead, it might research your industry, analyze your target audience, generate creative content ideas, suggest distribution channels, and even help you create timelines and budgets, all while working towards the overarching goal of building an effective marketing strategy. So the combination of these four characteristics, autonomy, advanced perception, sophisticated action capabilities, and also goal-oriented behavior, creates AI systems that can work with minimal human supervision while adapting to new situations and requirements. So this represents a significant leap forward from earlier AI technologies and also opens up possibilities for automation and assistance that were previously impossible to achieve. Let's break down the technical architecture of generative AI agents into essential components to understand how these systems actually work. Now, at its core, a generative AI agent combines two fundamental capabilities: the thinking power of large language models and the practical ability to execute tools and also take actions in the real world. So the architecture follows a pretty straightforward but powerful pattern. When you give an agent a task, the system begins with a planning phase where the large language model serves as the brain of the operation. So this planning component analyzes your request and then formulates a series of action or creates a roadmap to achieve the specific goal that you outline. Think of this like having a very intelligent project manager who can look at complex tasks and also immediately understand what steps need to be taken, and also in what order, and also what resources will be required. So during this planning phase, the large language model guides the agent through understanding exactly what you're asking for, and then also selecting the most appropriate tool from its available inventory. And finally, structuring a logical sequence of actions that will lead to the desired outcome. So the sophistication here lies in the model's ability to reason through complex problems, consider multiple approaches, and then also choose the most effective strategy based on the specific circumstance of your request. Now, once the planning is complete, the system then moves into the action phase. So this is a part where it executes the tools that were selected during the planning phase. This is where the agent transitions from thinking about what to do to actually doing it comes in. The action capabilities can include a wide variety of functions depending on what tools have been made available to the agent. For example, read-only actions might involve retrieving documents from storage systems, searching through databases for specific information, or gathering data from various sources. Write actions, on the other hand, allow the agent to modify its environment by sending emails, updating database records, creating new files, or making changes to existing systems. Now, what makes this architecture particularly powerful is the feedback loop between planning and action. The agent doesn't just execute a predetermined sequence of steps and then hopes for the best. Instead, it evaluates the output from each tool and also the action that it takes. Then it uses that information to adapt its approach as needed. So if something doesn't work as expected, the agent can replan or escalate to alternative strategies. If an action succeeds, it can use the results to inform the next steps in the process. The tools themselves are the specific resources that extend the agent's capabilities beyond its own internal knowledge. So these might include application programming interfaces that connect to external software systems, database connections that allow access to stored information, web services that provide real-time data, or specialized software functions that perform particular tasks. The key insight here is that these tools allow the agent to interact and also modify the world beyond just generating text responses. This architecture creates a complete cycle where the agent receives input in the form of a task, processes that input through intelligent planning that's powered by the large language models. It can then take concrete actions using the available tools and then produce meaningful outputs that accomplishes the original objective. The result is a system that can understand natural language requests, reason about complex problems, and also execute solutions that involve multiple steps and interaction with various systems and databases. The beauty of this approach is its flexibility and extensibility. So by changing the tools available to an agent, you can dramatically alter its capabilities without modifying the underlying intelligence. This means that the same planning and reasoning system can be adapted for customer service, for data analysis, for content creation, or countless other applications simply by providing it with the appropriate tools for each domain.
So there it is. That's how AI agents think, plan, and actually get things done. If you found this useful, hit like, share it with someone who'll enjoy it, and subscribe to our YouTube channel. Great learning.